We are Group 21, and our final project is the file system attribute. Now, first, I'd like to go into detail on what exactly a file attribute is. Well, a file attribute just contains pertinent metadata for a given file, and these attributes can be very extensible. You could have things like ownership, it could be the file color, it can has very many use cases because an attribute is simply put is just a null terminated string that has an associated value. Now, for operating system, this has several technical implications, and you could use this for your access control list. And so these attributes can have permission information about who is exactly can access that file and what different permissions that they have. So as you can see, there has very many use cases at the operating system level.
In order to approach our project, we had to understand the problem first and break it down into 3 parts to complete it. The first step was to create system calls to set, read, and remove the attributes for any given file. The second goal was to write driver programs to test our functions to ensure that the storing, reading, and removing attributes work for each file. The final goal was to incorporate all the system calls into the Linux kernel. Towards that end, our objective was to create a timeline that makes the best use of our individual strengths to complete the project on time.
Hello, my name is Mahdi Sharif. I assumed the role of lead kernel developer on the team. I was tasked with the compilation of and execution of the syscalls on the kernel. Part of my role was to debug the code and get it running. I also implemented a syscall and the user test.
Hello, so my name's Alana Walton. I led the group as project manager, and I performed all the written duties of the group. I made sure I updated all the documentation and I kept the wiki up to date. But I also was a developer and I contributed a syscall, and I was also around, to assist my team members on wherever they needed me.
Hello everyone. For the final project of OS class, I mostly worked on implementing the syscalls for the file system attributes, and I also worked on writing the user test programs. I closely worked with Mehdi, who was compiling and testing the code.
My name is Kanta Wenda, and I was the assistive development expert. Some of my tasks include creating the user space test programs and contributing to at least one system call.
As the project lead and to just keep everyone organized and on the same track, I developed a workflow plan. So I'd create the plan, then we'd work on the solution, compile it, test it, and then if we received errors, and that's when we go through the cycle again. So to kind of fit the needs of the group, I made sure that we created a project timeline and we were able to, estimate how long it would take us to do this. The assumption that I made was that the ramp up time would take a lot longer than the other times once we got into the swing of things. So I gave a lot longer time to finish the first syscall relative to the other syscalls. Now what you see in white is where we were successful up until. So once we approached the 2nd of December, that's when we started having problems. We realized all the calls weren't running in the kernel. That's when we started we started to pivot to work towards a solution so that we could complete the project in a timely fashion. So now we'll start to get into the solution that we actually created for our project.
Appending syscalls. I will briefly explain how we added and ran syscalls on our kernel. Our first step was to append the directory that housed our code on the kernel's makefile, which allowed the compiler to find our syscalls. Secondly, the function prototypes are added to the kernel's syscall header file with the prepended modifier ASM linkage to allow parameters of the function to be present on the stack. Lastly, we appended these 4 lines to the syscall table. This step provides a pointer to each function. To run our calls, we had to reboot our system following the recompilation of the kernel and installation of kernel modules.
I'm actually very proud of the work that we were able to pull off. We built all 4 syscalls in C, and I got them to run on Xcode on my personal machine, and we added them to the syscall table, and to the syscall header file. But unfortunately, all of the syscalls weren't able to run on the kernel. With more time and more resources, we'd like to investigate that issue further, but we believe it has something to do with the formation of our makefile. Our makefile is unable to compile all the object files together, is what I believe is happening, because um, when I looked into the issue further, we noticed that rearranging the methods determined which one was actually being found by the kernel. So, with more time and more resources, we'd like to investigate further. At this point, what we have is we have functional code that runs in C and on Xcode, but that does not function well inside of the kernel. So I don't want to make this video too long, but I just want to say thank you for taking the time to listen to this video. Thank you for the project. It was actually a great learning experience. I learned a lot about operating systems and how they work, and my whole team thoroughly enjoyed working with each other. Thank you very much, and good night.